So finally, I'm going to talk about the curvature of y equals fx. Well, we can first change this function into a vector function. So how can we do this? So we choose x the parameter, so it can be written in this way. So now we successfully changed this function into a vector function, and the curvature to derive the way to derive the curvature of this function is quite similar to that of the vector function. So let me write the curvature of the vector function first. It is so since we know Rx, we should also know the first derivative of Rx. So R prime x equals to I plus so R prime x equals I plus f prime x j. And we also need the second derivative of Rx to describe the change in direction of Rx. So it is f2 prime x j. Oh, so at here, R prime t is this one. And R2 primes t is R2 primes x. So we take their cross product. And here, since j times j is 0, they are parallel vectors. We only left I times f2 primes xj. So finally, we derive f2 primes x k. So the magnitude of this one is the magnitude of r prime t times r2 primes t. And also, it needs to it needs to be divided by the cube of the magnitude of r prime x, which is this one. So at last it can be written in this way. So this formula is the curvature of function like y equals fx. The method is just to change y equals fx into the vector function, and the following ways are just the same as those of vector function.